It smells, it gets on you. But that's okay because to me, urine is pretty exciting.
This is William Tarpe, an environmental engineering PhD student from UC Berkeley. His field of study basically harnesses the principles of engineering, biology, and chemistry to develop solutions to problems that negatively affect our environment. So environmental engineers tackle things like air pollution, contaminated water, and reducing garbage waste. But like any field, there are outliers. Like Will. Will spends all day, every day, transforming pee into liquid fertilizer, attempting to spin gold out of something that the rest of us just flush away without a second thought. And I mean, it's gold in color, but it's also valuable. I'll just let him tell you.
We focus on the nitrogen in urine because it's in fertilizers that people buy, and it's also in urine. So our big idea is to extract the nitrogen preferentially out of urine into a product that we can sell.
Now, Will doesn't plan on becoming the world's first pee millionaire. Urillionaire. Anyway, his motivation for making pee profitable is actually toilets. Because while basic sanitation is something that many of us in the West take for granted, for 2.4 billion people around the world, it's a very real public health issue.
Sanitation to me is really fundamental. It affects so many parts of life that we don't think about. The big purpose is to find ways to make sanitation self-funding. So that's the really big idea. How can we create value from something that's normally waste? And in doing so, generate the money that will help us proliferate more toilets, help us build more toilets.
To build toilets, you need money. So you need a product to make that money. Fertilizer contains nitrogen, phosphorus, and potassium, all chemicals that are naturally found in your pee. So for 4 years, Will has been working on transforming regular old urine into a nutrient-rich fertilizer. Of course, in order to do that, he needs a steady stream of pee for his research.
So when I'm here in Berkeley, we have to file paperwork to basically get urine from my lab mates. And so we're a pretty enterprising bunch. We're environmental engineers. It's not a hard sell.
Once Will has collected enough, he then has to let it sit for 1 week. He called it curing. Ugh, amazing.
When we excrete urine, the nitrogen is present as something called urea. And that's an organic compound. And then throughout about a week's time, that gets hydrolyzed, meaning in the presence of water and an enzyme called urease, that urea gets turned into ammonia. That's our starting point. Because the ammonia we can work with, it's more mobile.
Ammonia is a compound of hydrogen and nitrogen, but as it's still mixed up with lots of other chemicals present in urine, Will had to develop extraction methods so he could isolate the valuable nitrogen and make it into fertilizer. So far, he's created 2. The first method is called electrochemical stripping. Will uses an electrochemical cell with 3 chambers that can selectively filter nitrogen out of the urine. This is how it works. Pee goes into the first chamber. Then into the middle goes a really dilute salt solution. When electricity passes through the electrochemical cell, the ammonium, which is positively charged, is pushed through a membrane out of the pee and into the salt solution.
So then we get things like ammonium, sodium, and potassium. So we've gotten just 3 things out of the urine. But now our job's not done. We still have to get just the ammonium out.
Once that pee party has moved into the middle chamber, the electrical charge forces the solution to form hydroxide ions. This changes the nitrogen from a liquid to a gas, which allows it to move into the third chamber. The gas is then mixed with water, and voila, liquid fertilizer. The second method, though, seems to be a bit more efficient. It's called an ion exchange column. Basically, it's a tube filled with a resin material that is negatively charged. Think of it like a water filter. The nitrogen is part of the ammonium, which, by the way, is positively charged, So
we pass urine through a column. This time the nitrogen goes onto the resin beads, those spheres, and then the rest of the urine passes through. And now we can take a really dilute acid and pass it over those resin beads, and now the nitrogen will go back into solution.
Now, this all works perfectly well in a lab, but Will wanted to see if his innovations could work in a real-world setting, somewhere where sanitation is a real problem, so he partnered with Sanergy, a company that builds toilets in the slums of Nairobi, Kenya. Sanergy already collects feces and turns that into fertilizer, but before Will's innovations, they were just disposing of thousands of liters of urine every day.
So this past summer, we were actually testing both of these technologies side by side. And doing it in the field with real urine that's collected every single day. I love being in the field, and for me, I like being close to the people who use the technology. So I like looking at the toilets and seeing, okay, how would I actually use this, right? That changes your design process so much.
And after testing his innovations in Nairobi, Will is definitely thinking about the future. The biggest challenge, how to turn those thousands of liters of urine into fertilizer.
I'm really good at doing this in lab on my small filters and my small test kits that I've built, right? But then it's, how do I make this big enough to treat 5,000 liters of urine a day? In comparison, right now we treat about 5 liters of urine a day. How do we scale up the costs, the process, making sure the process still works at the same efficiencies that we've gotten it to work at in the lab?
If Will is able to scale up his idea, his work could help transform the lives of billions of people on our planet.
I wanted to do things that had environmental implications and that had impacts on people's lives. So combining those two things, it's no surprise that I ended up doing environmental engineering and basically ended up researching the chemistry of urine. So yeah, those are the things that excite me, but I think it's really how I can bring my training and my passions to bear on an important problem.
We want to take a moment to thank our partner, the Blum Center for Developing Economies at the University of California, Berkeley, an innovation and research hub that is tackling issues in global poverty. Make sure to check out some of their incredible work by visiting blumcenter.berkeley.edu. Technology really is changing life in the developing world. For example, now cell phones can be used as handheld microscopes to diagnose malaria in just 30 seconds. Want to know more? Check out this awesome video from Seeker Stories.
So the way this works is you slide the phone into the holder here, and then we run a app, just like you would if you were loading up Facebook or Gmail.
We've all heard one man's trash is another man's treasure, right? That's totally this story. Have you ever reused something that was once trash? I found a great couch in the garbage once. Let us know in the comments. Make sure you come back here every day for more D News, and thanks for watching.